All right, so thank you everyone for joining today's session on StarRocks 3.2 release. My name is Albert Wong. I am the developer advocate for StarRocks. So let's go through today's agenda and the contents for today's session. So for today, we're going to talk a little bit about the state of the OLAP landscape. We're going to talk for some of the new people, what is StarRocks? Because I want to give a little short summary of what that is. We're going to talk about our release timelines. And then we're going to talk a little bit more about the major features in 3.2 and touch a little bit on CelerData Cloud 3.2. And then what are the plans there? So state of the OLAP landscape. So for people who are not very familiar with OLAP databases, as you can imagine, there's really two types of databases in the marketplace. There's OLTP. Think of this as low latency databases that are used for a lot of the transactional use cases that you have. So think of it like storing is financial data, like updating my checking account with adding money, taking out money, whatnot. And the common databases you see in the market for that are things like MySQL, Postgres, and Mongo, right? And they are very, very good when you do insertion of one single record and also pulling out data on single records, right? And just to give you an idea about that, insertion typically for OLTP is around 2 to 8 milliseconds. And OLAP systems, which I'll talk a little bit more in detail, are much, much more slower than that, right? Some of the ones that are out there are actually in the large second ranges. And depending on how much data you have, it's even takes minutes for them to do an entire batch, right? So we are not an OLTP. We are a OLAP database. And talking about the OLAP databases in the marketplace, the common ones that you see in the marketplace are things like Redshift, BigQuery, Snowflake, Teradata, Netezza. Those are the ones that you typically see out in the marketplace. And so if you see some of the common trends in the OLAP marketplace, you'll see that as time has gone on, so OLAP started appearing in the late 1990s with DB2 Warehouse. They were the forerunner from that standpoint of building what are analytical workloads. And as the 90s went on, the 2000s, 2010s, and 2020s, what do the 2020 new generation of OLAP databases have? So one thing is that they are cloud native. And what we talk about that is things like separation of compute and storage, so that you have is the ability to have is an elastic tier for the compute usage. And then you have also a different elastic tier for storage. And we can go into a little detail later about what that means. But common other databases that do a separation of compute and storage is Snowflake and BigQuery. Redshift actually isn't that. Redshift Spectrum, which is their newer version, actually does that. But their older the older Redshift actually is what we call the shared nothing model, which is the data is actually stored on the nodes themselves. Another thing about cloud native is really that it's built around containers, and also it works in Kubernetes environments, right? The newer set of databases were born in the web. They were born when containers are around, right? So this is the last 10 some years. Some of the older databases were built on a, say, for instance, a VM type of environment, and they kind of like built little features in it to make it more cloud-like, but they're not natively built into the cloud, right? And so I like to make this distinction because that's how we also look at dividing up the marketplace. Another trend that you see in the OLAP marketplace is things like sub-second response time versus minutes and seconds, right? So when you're doing queries from that standpoint, we have, say, for instance, in StarRocks, we have customers or users in our community that does, across 10 petabytes of data, they can do ad hoc queries and it comes back in less than 2 seconds. And in some other situations, we have other community users that do, terabytes, if not petabytes, and they respond back in any ad hoc query, or maybe even, other queries in general. They will get back responses of less than 1 second, right? And so this is a very big distinction, because the traditional OLAP systems, if you've actually used them, right, they come sometimes in low seconds. Maybe it'll take 2 or 3 or 8 or 10 seconds to come on back. And if you remember, so when, in the early, 1990s and 2000s, it used to take maybe a minute and a half or a minute, 60 seconds for even queries to come on back. And that was okay. But you're talking about the newer generation. They're expecting sub-second or low single-second response times for queries. The other big trend that you'll see is that instead of doing, say, for instance, batch loads that happen, say, for instance, on an hourly basis or every 5 minutes or every minute, they're looking at streaming data in. So you're talking about more of like event-driven architecture. So as the, say, for instance, OLAP database changes, they put data on a queue, and that queue drips in real time into the OLAP system, so that you get is near real time inside the data environment. The other big thing that you see in the newer OLAP databases is this idea of mutable data versus immutable. So a lot of OLAP systems are purely immutable, meaning that, as data comes on in, right, data doesn't change. So say, for instance, you are saying, like, I have $100 today in my bank account, right? You see that entry come on into the system, and then you see is, if I want to make a change, you don't make a change to the older record. You basically append newer data that says, I took out $20 out of my bank account. And so therefore you see 2 transactions, one for 100 and then later on a minus $20, right? The idea of immutable is that you go back and you would look and you can go and see that this piece of data has changed, and now you're only looking at it as $80 from that standpoint, right? You don't actually need to see and all the quote unquote delta changes that have happened between that, right? So this is a newer concept of having this immutability. You also see the idea of storing the data not in local SSDs, but in object stores. That's primarily because it's a cheaper way for you to store data. So say, for instance, the cost difference between EBS. So say, for instance, if you spent $1 on EBS, object stores are between 5 to 10 cents. So you're saving, 90% of your storage costs by moving up to object. And so the question then becomes can object stores be as fast as SSDs? And for a lot of our cases that we've done at StarRocks, we can get near SSD performance, right? And I say near, it depends on your use cases, but you can get pretty darn close. Plus or minus within 10%, 15%, depending on what it is. The other thing that you see with the newer OLAP databases is this idea of supporting is an open table format versus a native product format. So for instance, in StarRocks, our native storage format is the StarRocks table format. So when you initially install StarRocks, that's the format that we use, but we also have the ability to use, say, for instance, query data from Apache Iceberg, Apache Hoodie, Delta Lake, and from Apache Hive and Apache Pymon, right? And those other table formats that I mentioned are open source, open standards. And so the idea is that it's not controlled by a single quote unquote, it's not quote, controlled by a single vendor, embedded into a product, but yet again, it's a format that everybody can go and use. Another one is around this idea of data warehouses, data versus data lakes versus data warehouse, data lakehouse, right? And so this idea is that used to be where really curated information was only available in the data warehouse, and all the other data that wasn't curated, maybe not key KPIs, but data that you wanted to store, but you didn't know exactly what you're going to use it for, we're just going to throw everything in the data lake, right? And there's this ongoing thinking that says, why isn't the data in the data lake, the structured and unstructured data in the data lake, why can't that be a top citizen? Why can't that be a first class piece of data, just like the data in the data warehouse, right? So this idea that it's being emergent is that why can't we store, instead of having two places of storage, the data warehouse and the data lake, why can't we combine the best of both worlds, being that the cheap storage for structured and storage in a data lake, and providing data warehouse capability on top of that data lake, right? Why can't we just merge those two concepts and build them together? Instead, that's why you have this idea of the data lake house, right? A building like a data warehouse on top of the data lake itself. So all the vendors you see, they're all moving towards this. And I'll give an example how Snowflake is doing it, right? So Snowflake, from their point of view, is that in the past, they used to be proprietary everything. The compute level was all proprietary. The table format they only used was the Snowflake table format, and the storage format, even in themselves, was their own blend of Snowflake. You couldn't see anything underneath what was going on. And as time has gone on, you see announcements from Snowflake that they're saying, "Oh, we're going to support the open table format Iceberg. Oh, we're going to support Parquet underneath," from that point of view, right? And then you've got other different models. Like, for instance, from Databricks. Databricks thinks that, oh, the compute layer we're going to make proprietary, but underneath the table format, we're going to support Delta Lake, and then the storage format underneath is Parquet, right? So all the other tiers may be open source, but the compute layer isn't. And then you've got the other vendors in the marketplace, like ourselves, like StarRocks, and we've got other vendors in this marketplace, right? And they're all entirely open source, and we support multiple table formats within our product, and we also support other storage formats, right? And so this idea of open source entering into the OLAP marketplace has dramatically changed the OLAP landscape within the last 3 to 5 years. And we expect to see this ongoing as time goes on. And I think you're going to see this shift of where there's the traditional data warehouse and this data lake house. These concepts are going to be merging more and more together. All right. So what is StarRocks? So StarRocks is an open source query engine that delivers data warehouse performance on the data lake. We like to think ourselves as the fastest and cheapest way for you to go do this. And one of our biggest benefits is that people benchmark us all the time and against all these different OLAP products in the marketplace, and they like us for several reasons, right? They like us because we're very fast on querying, and I'll go into a difference why, and we're able to go do joins at scale. So before I go into a little bit about some of the product details from that standpoint, so I wanted to describe a little bit about the relationship between StarRocks and CelerData. So one of the things that we did was that we donated StarRocks to the Linux Foundation project, or Linux Foundation. And as part of donating to the project, we give up our trademarks and our intellectual capital. So as a company, we cannot call ourselves StarRocks anymore, right? So we the product is called StarRocks, a Linux Foundation project, and the company who sponsors StarRocks is CelerData, right? Now, we're not the only set of committers for the StarRocks project. There are other committers that are from different companies that contribute code to the StarRocks, but we're probably the largest in terms of overall code base, right? And a little bit about our history too is that we started the birth of StarRocks was started in 2020. We are initially a commercialized fork of Apache Doris. We've rewritten 90% of the original code base from Doris, so we don't think we are Doris anymore because we've written so much of it. We have some of the architectural concepts are very similar, but we've kind of really drifted away from Doris's design and capabilities from that standpoint. And also a little bit about CelerData itself. So StarRocks provides there's a community version, but if you're interested in a enterprise version of StarRocks, so it's StarRocks plus some additional features like security. There are some connectors. There's also a managed service. You can contact CelerData, and they will provide as those type of features and to your company. So I mentioned a little bit about why people like StarRocks, right? And so these are just some of the major points of why, right? So number one is this concept of not needing to go and move data into or ingest the data into the database, right? So we can directly query your data on the data lake. So if your data is already in Iceberg, or it's in Hoodie, Delta Lake, Hive, right? We can just directly plug into it and we're able to go query. If it's not in that, then I would recommend that you ingest, and then it could be StarRocks table format data on the data lake. Another reason why people like us is sub-second joins and aggregations on billions of rows. So we have internal benchmarks that we can do billions of rows with one CPU within 1 second, right? And this is one of those things that vendors say, or community projects say that they can go do. Try us, test us. I would love for you to go and take whatever data set that you have, load it into StarRocks, and then do these joins, right? And our biggest thing is that, compared to some of the other open source OLAP projects that are out there, a lot of them tell you to denormalize. And one thing with denormalization is that you have to basically build as complex pipelines, right? Because why? In the OLAP, it's in, like, say, for instance, third normal form, and then you have to write all these data pipelines to denormalize it and then load it into OLAP. Now, why is that? It's because it was the way that we've always done it. Ever since 1990s, we kind of knew, and Teradata, IBM would tell you, if you want better performance for OLAP systems, you have to denormalize everything, right? And then you have essentially basically make a flat table. And so and this has been overall the design for the last 20, 30 years. And it's not until we got the new generation of databases and they're able to take advantage of things like SIMD, which is single instruction multiple data, which is a key part of CPUs nowadays, right? That allows us to go and basically do joins at scale. And so you can simplify your data pipeline and make it easy. So it's third normal form inside of your OLTP. You can have third normal form inside of the OLAP, and we support every single type of join that you can go to, inner, outer, you name it, right? We support all the joins, right? And feel free to benchmark us. See if truly our joins will go and scale, right? I challenge you to find where we can't go and do it. Third big thing that people like us is being able to do concurrent end user requests, right? So a lot of the OLAP systems out in the marketplace, they will go and they tie a lot of them will go and say, oh, we don't want to do user-facing analytics or real-time analytics in against our system if you have a lot of concurrent users. So they'll top out like 100 concurrent users, and then when you go past the 100, it gets slower and slower, or they ask you to go and say, for instance, just limit the amount of requests in the system from that standpoint. So originally, StarRocks was built as to support is the ad bidding process. And as you can imagine, when you bid for ad keywords, right, you need not only you need its current prices, but you also need historical prices in order for you to go and say, I'm going to buy, say, for instance, this keyword of red shirts for $5, right? But not only you have this, current info and historical info, you also need to support thousands of users, right? Because all these people that are logging on in, it's not that you have a few people that are bidding on keywords. You have hundreds, if not thousands of people that are bidding on keywords, and they all expect low latency, right? And so we had to design a system that was able to go and support those type of concurrency all the time, right? And we think we've done a pretty good job of this. We have this idea of what we call is front end nodes that you can horizontally scale, and it's very common for us to have users of our community product to have hundreds, if not thousands, of concurrent users that are doing ad hoc queries all the time. Another thing is cloud native with separation of compute and storage. So I mentioned this a little bit before. This is container-based deployments along with elastic tiers. So if you look at our architecture diagrams, we basically have two tiers. So we have what are called front-end nodes, which is the MySQL emulation layer, and you can elastically horizontally scale this. Right. And then we have is the back end nodes, BE nodes or CN nodes, and they provide is the persistence and data persistence layer for us. Right. And so you can have this idea of saying, hey, I want is 3 compute nodes and I want 10 storage nodes from that standpoint. Right. Or I want to have, 10 front end nodes only to 3 storage nodes. So you can elastically scale them as you see fit, right? I also mentioned one of the big things was joint performance on scale. We also support denormalization. You can denormalize if you want to. However, I would say majority of the community users want to do joint performance because they just want to simplify their life, right? It's so much more easier if you could write a pipeline that says, oh, it's this third normal form in OLTP. I want to just copy the exact same schema that I have from OLTP into the AP, load it into the system. Maybe I do some optimization like partitioning and whatnot. But I want to be able to essentially keep the same schema. So that way my pipeline is relatively just, an insert, just, a CTAS, a create table as insert, or, or some easy mechanism like that, right? So like for like. And this really reduces complexity. You can imagine that that for any schema change that happens, you don't have to go and remodify maybe all of your pipeline scripts to support the new schema. The other big thing that people like is not learning is a new database protocol. We emulate the MySQL protocol. So if you're familiar with MySQL, you can use the same MySQL statements. We also support the Trino dialect. So if you are currently a Trino user, right, on the query side, you can just basically tell our engine to say, understand the Trino dialect and just execute those queries I believe it's like 99% of everything from Trina will just work on us. And obviously the MySQL protocol, since we emulate it, all your CRUD-like actions, your inserts, your reads, your your selects, your updates, your deletes, you just use the same syntax that you would use in MySQL, and you can use it inside of our system itself. So let's talk about use cases that what StarRocks was designed for. So I mentioned a little bit about user-facing analytics, right? So this idea of user-facing analytics is essentially allowing the ability for end users to explore and analyze the data themselves without the need for technical expertise. You guys might have heard of this as like citizen scientists, or just giving them the ability to just query as they see fit, right? And you can imagine that this would be very scary for traditional data organizations. And they're like, what if you make a query that takes down our entire database, or runs for 3 hours and degrades the system? Or can we even support like the entire, developer organization to make any type of query on top of the system, right? And so building a database that, or a OLAP system that is able to support this requires us a change of mindset, right? This idea of saying like, we're going to provide you a system that can address all these different use cases, and it is kind of, to be honest, revolutionary, right? And so we design features in our products to support this type of thing, to support these type of use cases, so that you can provide is this type of service to your own developer teams, or even to your end user customers, right? So we have customers who basically say, oh, I'm going to go, as part of my product, I'm going to give them is a dashboard for them to be able to do any type of report or any type of SQL statement, so they can create whatever reports from the data that we have in our system. Not just the limited amount of tables that we foresee for them to use, but we want to give them the access to all of the data that we have, that we stored on their behalf, right? And so that's what we try to go and do as a use case to support within our product. We call that self-service analytics, right? Embedded analytics is embedding our product into an overall other application suite, right? Being able to do real-time analytics is the idea of doing sub-second queries. We even want to do even the use case of saying real-time feeds. So say, for instance, I say, oh, I want to go and make an update in the OLTP system. How long will it take for me to be able to query that, right? And generally speaking, for the use cases that that the community puts on top of us, the idea is that we want to be able to, when the OLTP generates that piece of data, we want to be able to have StarRocks ingest the data and make it queryable in less than 10 seconds. Right, that's the goal that we want to go do. Now, of course, it's ****, how much infrastructure you need to go do it, right? How much data is being generated from the OLTP. There's a lot of variables in that picture, but I think the goal here is that we wanted that when the OLTP changes, right, we want this data to be queryable as soon as possible, within seconds. So that you can get, quote unquote, the same results, and you can get the benefits of the real-time and the historical data. Right. And as you move on from real-time analytics, now you can support things like asking it with like ChatGPT like questions, or you're able to provide is insight into your queries as you're running those queries itself, right? And that's really around augmented analytics. Another subtype of use cases that StarRocks addresses is yet again is like real-time analytics itself, right? I kind of mentioned this a bit better before, a little bit in the previous slide, but this idea of, say, for instance, if I instead of me waiting for a report that takes minutes to come back, or in a lot of situations, an hour to come on back, what if you can give that data to them in real time, right? So I'll take you, I'll give you a case, right? So a lot of, say for instance, you do credit cards, right? And you do credit card transactions. Credit card transactions for most of the legacy systems, it takes an entire day, right? You see it when you write a credit card, it says there's a pending, but there's not a settlement that happens within minutes. The settlement typically happens 24 hours later. Why? Because they have to wait for the night process to happen. And that's when all the, transfer of money happens, and making sure that you have, the right amount of money in your bank account, you're not over withdrawn, or you may be withdrawn, and there's all these other processes that kick on off, right? And the reality of it is that the system was built with this design of saying, I need to have all this processing to happen, when I can get dedicated access to the system, or near dedicated access to the system, right? So therefore, all your reports, you really can't get any what's happening real time in your environment, right? The only way for you to know how much money you have in your bank account is to wait 24 hours later, after all the settlement has completed, and then you know how much money you truly have. Now, what if you were, building a new financial system, and you're like going, hey, I'm going to tell you real time how much money you have in your bank account, right? So now you're talking not just 24 hours. Now you're not talking about within hours. You're talking within seconds of whether or not you have money that is being taken out or put into your bank account, right? And you have a real-time view of what is going on. What type of other decisions will we be able to make, right? Now you're not guessing whether you're going to be overdrawn. You're going to actually see it in real time whether or not you can actually make this purchase or not make this purchase, right? And so this unlocking of real-time use cases, right, is building a new strategic advantage for a lot of the different applications that are out there, right? So I would behoove all you guys to look at is like, what if we got all this data sooner, faster, right? What other things that we can go and provide as a competitive advantage within our product or within our industry by having this type of capability? All right. Talk a little bit about is StarRocks architecture, right? So StarRocks architecture, I mentioned this also a little bit, right? So we have, if you've ever used our product a little bit before, right, we have as a way for you to go and access the data. I told you through MySQL. From that standpoint, we have some admin tools that help you go and manage this. We have the StarRocks vectorized engine that processes requests, and we sit on top of the Delta, on top of the data lake with different formats that we support. If you want to see more of these architecture diagrams, you can get them off of GitHub. And we also support 2 different types of deployment architectures, right? So we have the shared nothing architecture. So this is much, much more closer to how Redshift is actually deployed, where storage and compute is on the same VM, on the same node from that standpoint. And then we have is the shared data architecture, which is slightly different. Storage of the data is actually stored in an S3 bucket. And what happens is that the compute nodes are in containers or in the VMs themselves, right? There are pros and cons to each of the architecture. Things like Snowflake and BigQuery are designed on the shared data architecture and not on the shared nothing. Generally speaking, I see that some of our customers, we see kind of equals on both. So if you're, say, for instance, small environments, developer environments, the shared nothing architecture is much, much more easier to deploy. But as you get bigger and bigger amounts of data, because you're storing the data in S3 bucket, and I mentioned this in a little bit in the beginning of the presentation, it's like 90% cost savings by moving off of SSDs to S3. A lot of the big organizations, like the petabytes, the zettabytes type of organizations, they love the shared data architecture. All right, so let's talk a little bit about StarRocks roadmap, where we were in the past and where we're in the future, right? So lots of things have happened in the StarRocks, right? I mentioned that we're about 3 years old, right? And so in the 1 series of our products, we were really working on the core capability. We're talking about rewriting 90% of the Apache Doris code base, right? So we provided a new cost-based optimizer. We provided a new vectorized ingestion engine, right? Support for more types of joins, supports for more types of data types, right? So we spent a year basically rewriting some of the core capabilities of the OLAP database, right? And then in year 2, we expanded that to support, say, we envisioned that supporting the data lake was a critical distinction among us against other OLAP databases. You know, the idea of supporting Iceberg and Hoodie was, to be honest, not a lot of other OLAP databases didn't support it at the time, right? And so we wanted to be one of the first that supported those type of data formats. So we spent a lot of the V2 to support those designs. In V3, we introduced the idea of the shared data architecture. So before that, 1 and 2 was a shared nothing model, and then V3 we introduced shared data. And with the shared data across the 3 series, we've been moving capability that was in the shared nothing into the shared data, right? And so things that, because we introduced the new architecture, some of the capabilities need to be redesigned or re-architected. So it's not like we could just say, oh, everything that worked in the shared nothing will work in shared data. We had to go and re-optimize it to work on S3 storage. And so it's taking us time for us to move capability by capability into the shared data architecture. And we expect that with the completion of the 3 series, by the end of the 3 series, we will have parity between the functional parity between the shared nothing and shared data architectures. Talking a little bit more about is the 3 series roadmap. So I mentioned feature parity. The other thing that we wanted to go do was build more and optimize more of the core data warehouse features. So you'll see is more quality of life enhancements, and this is the files and the pipeline feature inside of the new StarRocks 3X series. It's a big help for some of us who've been using StarRocks for a while. And the other thing we wanted to go do is that we wanted to become the fastest query engine for not just the StarRocks table format, but all the popular open table formats. So we are optimizing ourselves for select capabilities within Iceberg, Hoodie, Hive, Delta Lake, and Apache Pymon. There's a great video. I'm not sure if you've seen it. I posted up on Slack, but there was a company that evaluated our Iceberg capabilities and had very nice things to say about how and why we are faster than other open source OLAP projects in terms of Apache Iceberg querying. And throughout the 3 series, we're going to be working on making all the open formats to be the fastest in the marketplace. That's our goal. Okay, so now we actually got to the 3.2 features. I know we burned a lot of time, 40 some minutes and whatnot, but I think it was critical for you guys to know what we're thinking about in our products. So 3.2, So as you can imagine, this is an improvement on some of our core capability and core capabilities in the data warehouse. And just like I mentioned, for us to make a better and better product for open table formats and to get some of the features that were available in the shared nothing into the shared data model. So one of the new features that we introduced was random bucketing. This is an easier way. Before you had to go and basically tell us what the bucketing you want to go do. This allows you to kind of make it much more automatic, right? We also have an optimized table feature that allows us to kind of do some performance enhancements about the way we do some of the querying, fast schema evolution for the table structure. And we also have this new capability about automatic storage cooldown. So in StarRocks, if you use the community version, you can actually mix and match hard drive disks. So you can have SSDs and the traditional spindle-based disks from that standpoint. And so this allows you to move basically data from SSDs to HDDs for efficient kind of hot, warm, hot, cold type of data management. Very cool feature, especially when you're storing lots and lots of data. For data loading and unloading, we're investing more into the files and pipe capability. So files, our goal here is to deprecate some of our other data loading tools that we've had in the past and move to this files capability. And that allows you the ability for you to easily load, Parquet files, ORC files, org files, and whatnot into the system. It's much easier than some of the other various tools we had to load in Parquet data, and we're enhancing that. We're going to be enhancing that throughout the entire 3 series. Pipe was a way for us to fix the issues of us doing timeouts when we load in gigabytes and terabytes of data into the system, right? So before, we used to tell you to manually kind of make the data size import smaller and smaller. So pipe basically allows you to go in, and we do that automatically through the tool itself. And so you don't have to go and break down these files into smaller chunks for us. There's also some enhancements too, so to the way we did for syntax. So this is like insert from files into files for us to have a more consistent behavior for us to load and unload. So these quality of life improvements will happen throughout the entire 3 series. Just look out for this as time goes on. We added for data querying is a new HTTP SQL API. So this is a way for you to access StarRocks without the MySQL client. You can just do HTTP calls straight into StarRocks itself. This is great for when you want to go and say, for instance, you have a reactive website and you don't want to use the MySQL driver. You just want to be able to just make calls straight into the database, right? This now gives you that capability, and it gives you what we've been talking about is this user-facing analytics, real-time analytics, capability for you guys, and treat the StarRocks more closer to OLTP, not a OLTP, but closer, right? We also did some enhancements for you to be able to optimize your queries itself. So we have a query planner, and we made it, and that's a great way for you to understand where are all the bottlenecks into your select statements and whatnot, and whether or not it's using a cache, whether it's using the materialized view. We've enhanced it a bit so that you can get even more detailed information on how to enhance your queries for performance. I mentioned a little bit about our goal is to move features on over from shared nothing to shared data. So we moved over some of the indexes for primary key to shared data and be able to persist that onto storage, right? S3 storage. So there was enhancements there. There was also enhancements to how we go and use cache across the various systems. Overall, I think you'll find that our shared data is just getting improved more and more over time. And this will happen across the entire 3 series. I mentioned also in some of the previous slides about us better supporting the various open table formats. So we've been adding support for the ability to have write abilities in Apache Hive. We already do it for Iceberg. We're working on some of the other table formats as the 3 series goes on. We also provide now is a unified external catalog. So before you'd have to build a catalog for Iceberg, a catalog for Hoodie, a catalog for Hive. Now you can have one catalog and they can have all 3 different types or 4 types inside of one single catalog. So now that allows you to do much easier for you to do joins across all these different types of data sets, right? Or you can do a join across Hive, Iceberg, and Hoodie at the same time, essentially, right? Also, a better giving you. We now store more data in the metadata tables within StarRocks. So this allows you to have better integration with other BI tools in the marketplace. So I think you'll find that as a quality of life improvement, especially if you're on Superset, Metabase, Tabular, and so forth. Materialized views. This is one of the best ways for you to get better performance in StarRocks itself. So obviously, if you just make queries against the raw data, the way you get better performance would have been better partitioning, for instance, right? But if you want to get even better, faster speeds, is to use a materialized views with some of the other caching abilities that we have, right? So if you are using materialized views from that standpoint, we are one of the biggest things that I like is now we have a tunable, transparent rewriting capability. So essentially with materialized views, when you do a query against materialized views, sometimes StarRocks will rewrite the query from that standpoint. And the problem is that when StarRocks rewrites the query in real time, it might not be the most optimal way based on the way that you've laid out the data and the workload patterns and whatnot. So now providing you a way for it to be more tunable, it allows you to get even better performance than what quote unquote StarRocks thinks the rewriting should be, right? We also have some other enhancements around is incremental refreshes for Iceberg and Paimon, right? So this is yet again is, being able to go and use the open table formats better and better and better. There is also another type of materialized view that we support. So this is called Synchronous. Most of the users use asynchronous. So this is analogous to a roll-up table. If you're familiar with this concept, we basically added some additional features for the synchronous materialized views / roll-up materialized views. New thing that also came out is this row column mixed storage. We are releasing this. I think this is a preview, but the idea here is that we are So StarRocks is a columnar database, right? So columnar meaning that we store things vertically. So say, for instance, if you had a column called employee number from that standpoint, right? We store basically the data vertically and as like, instead of the first name, last name, employee number, it's just a bunch of employee numbers from that standpoint. All right. Why? Because if you do things like the unique entry, unique command, that's much more faster than doing a for loop and then looking at every single employee ID number. It's just faster. You just look at the employee number and just do a count against it, right? So by us providing is row data inside of the columnar, we don't actually have to go and do for loops the entire time. And so this allows us to do, for specific use cases, a way for us to do faster lookups on primary key tables. Really, really cool. And then we've got a bunch of other various enhancements across the board, right? I think the bigger thing from that standpoint is supporting prepared statements now, being able to have better compatibility with Metabase and Superset. And also, there is this thing called the StarRocks migration tool. We built it in-house. But we are deprecating that in favor of Apache Flink 3.0 CDC. So the idea here is that if you're coming from a different database and you're trying to migrate from data, like, this is terabytes, gigabytes, terabytes, petabytes of data, right? We encourage you to use the Apache Flink toolkit. There's a article of how to go in and be able to use this tool to migrate your data from one database to another. All right. So I'm going to touch a little bit on CelerData Cloud 3.2, right? So yet again, this is outside of our community product. We're going to talk a little bit about the commercial offering for CelerData. Now, there is a bunch of other enhancements. They get all the community stuff, but one of the things that they will have that the community won't have is this idea of multi-warehouse. So, you can imagine if you're using the shared data model, you're like going, okay, if the compute nodes are ephemeral and storage is now up on S3, can't we just go and, have different type of workloads against that S3, right? So yes, up to a certain extent, right? So meaning that on a single cluster, you can go and access that S3. But what if you wanted to go and says, I have a cluster that is only dedicated to reads, and I want a cluster that's only dedicated to writes, right? And I want them all to point to the same same data on S3, right? So this capability is being released in CelerData Cloud. And so here I have a little diagram that says like we have a dedicated read for a business unit, and then there's a business shared read traffic cluster, and then there's a write traffic. And so the ideal use case that you have is like you're not writing all the time. So maybe you can scale that down differently. So the write traffic only happens because you're only doing writes maybe every hour. We only provision the StarRocks cluster for an hour, run it for 10 minutes to do all the writes, and then we shut that down, right? But then the dedicated cluster happens 24 hours from that standpoint, right? Or the read cluster, maybe it's peaky. Maybe it's like people only do all the reporting in when they come into the office, but they don't use it throughout the rest of the day. So why don't we elastically scale the read cluster to be 20 nodes at 9 o'clock in the morning, but by 11 o'clock, it's only 3 nodes from that standpoint, right? So this capability of having elasticity along with being able to isolate traffic for various business units or various use cases, we call this multi-warehouse, and it's going to be only available in CelerData Cloud. All right, so that's it. That's it for the 3.2. Thank you for joining the session. And so right now, I'm going to take questions from chat. All right, so let's see here. We have a question here that says, what are the best practices that you would advise incomers from other data warehouse systems? Yeah, so best practices, right? So it's really a case-by-case basis, unfortunately, because each OLAP database, if you're talking about, from Redshift, from Snowflake, or from ClickHouse, or from Druid, right? They all have strengths and weaknesses from that standpoint, right? And so I would ask these questions in the forums. And so then that way we can go and give you really, really specific advice coming back, right? Because in certain cases where, say, for instance, you're coming, for instance, from Druid, right? Most people who use Druid, they're normalizing data, right? And so our advice for you, best practice here, normalize everything back. Make it easiest for you to go and do pipeline, right? Make the pipeline as easiest as you can on possible, and then just optimize things on the StarRocks side, which is through maybe partitioning, through replication of the data itself, with the ability to go and maybe use materialized views, enable caching on the various queries, right? So we cache the intermediate queries along with the final queries, right? Enable the ability for you to do predicate push down, right? That kind of stuff, right? So I always kind of think of it where make your life simpler and then push those problems onto StarRocks as much as possible. Now, if you're coming from another database, like, say, for instance, from Snowflake, right? Some people really write really specialized Snowflake queries, right, to get the maximum performance out of it, right? And then I would tell you in that best practice to sort of say, let StarRocks's rewriting capabilities handle that for you, right? Write the SQL statement that makes it easiest for other data engineers and developers to read. And then let StarRocks go and rewrite that to make it the most optimal query inside of the StarRocks engine, right? So yet again, this is trying to make your life easier. Don't try to figure out how I should rewrite this in a certain way because I want to use this capability in StarRocks, right? So make it, build a simple case, make the readability use case first, and then let's evolve that query statement and or enable certain features inside of StarRocks to get you better performance. Right. Okay. Next question here is, what's the difference between community and enterprise to manage service, right? So I mentioned this a little bit before, but essentially community, the enterprise and the enterprise version, which is also deployed on the cloud version, has security features beyond the community. So community, for instance, doesn't have, if you connect with the MySQL drivers to do queries, it doesn't even have TLS capability. It's basically clear text the entire way on through. So if you want the TLS connectivity between your MySQL driver and StarRocks, it's only available in the enterprise version and in the cloud version. And then other features, like, for instance, encryption at rest and whatnot, these ones would only exist inside of the enterprise and or cloud version. The other thing that you will typically see is the managed service, right? So a managed service is not only going to get support, which is also available in the enterprise version, but you will also get is full, management of the instance itself. So things like maybe if there's an issue or node down or something like that, there are tools and capabilities that the managed services provides to either notify you or bring those systems back on up. right? So just think of it as it's the same thing as any managed service that you would, get from Snowflake, Redshift, BigQuery-ish, right? There are some slight differences, but that's generally the idea of managed service. Next question. Is using HTTP faster than using the MySQL driver? Yes. So here's the thing. Because we emulate the MySQL driver was designed for OLTP. So OLTP is, single records, very, very fast inserts, very fast updates and deletes from that standpoint. But when you're trying to do something like, I want to load 5,000 records, right? Like MySQL will do it, right? But does it do it optimally? No. That's the problem, right? And so when you're loading in lots and lots of data, so this is when on the inserts, right? That's why we provide a tool like Streamload. And Streamload basically bypasses the FE, the emulation layer, and goes straight to the back end nodes and then starts persisting that data, because then we can avoid the deconstruction of the MySQL protocol. That's one aspect. And also, we don't have to pay for all these other penalties along the way, right? Of processing all the MySQL, syntax from that, and then go straight into start persisting the data. And we also have a commit all or nothing. So we'll either give you, if you're committing with Streamload, 1,000 records, 10,000 records, we'll either say commit all or we'll roll back all, right? So you'll get that type of notification from that standpoint. There are other enhancements, but generally, yes. So the MySQL, I would give you the general advice is the MySQL driver is primarily used for selects, deletes, and updates, right? Mostly for selects, right? Because it's, you're pulling out data from that standpoint, and it's easy for you to use the MySQL syntax from that standpoint. And generally speaking, for inserting data, I would recommend is the HPP load, right? Now, say for instance, you don't want to use the HPP load, or is the performance that bad? If you're doing lots of data, yeah, the time that you're waiting, maybe it's better for you for the HTTP. But that doesn't mean don't use the MySQL driver in all instances, right? Use the MySQL driver, right? It's just that if you're wanting to get the best performance, right, then you should look at the HTTP. Next question. Is moving the persistent data from FE to shared storage on the roadmap to shared storage? Oh, sorry. I'll repeat again. Is moving the persistent data on FE nodes to shared storage on the roadmap so that the entirety of the data and metadata exists in cloud storage? Yeah. So right now, there is FEs do store in the shared data model. FEs do store some of the data on local disk, and there is work to move all of it into cloud, right? So essentially, what happens is that if you needed it, if that FE nodes goes down, you would have to go and start back up as a new FE. And whatever quote unquote data or knowledge that it had, right, it had to start from scratch again, right? So it's like as if you're doing a cold start. So yes, it's being worked on. I don't have an ETA of when it will be finished, but we are working on it. Another question. Do you plan to use network file systems for data, maybe cold data like that on S3 or HDFS, right? So I don't quite understand this question, meaning that if you use the shared data model, you're going to store all the data in S3 anyhow, right? So we already support it today. If you're talking about the shared nothing, right? So in the shared nothing, I mentioned that the disk is stored is co-located on the same node, right? So all the data that you write with the StarRocks table format is going to be stored on local disk. Now, there is a slight star with it, is that what if you're using hoodie or iceberg data in shared nothing, right? Well, that data typically is stored already in S3. So what we do is we connect to the external catalog, which would in turn connect to those S3 buckets for getting the iceberg or the hoodie data, right? So, and, I think I would ask for you to go and maybe ask a more expanded version of this question inside of the forums, and then that way I can go and give you a better answer to it. All right. So it looks like that's all the questions I see. Thank you again for taking time out of your day to attend this session. And I look forward to talking to you on the community forums or actually in one of our other web sessions or face-to-face events. Thank you again.